If one day the sun were to vanish, Earth would freeze, oceans would turn to ice, and life would slowly fade into darkness. But what if there are worlds that were born in that darkness? Worlds without stars, worlds that wander endlessly through interstellar space, invisible, cold, and silent. These are rogue planets, cosmic nomads drifting between galaxies untethered to any sun. For decades, we thought planets needed stars to survive. Now science is quietly telling us something far more unsettling. Some of these dark wanderers may not only survive, they may be habitable, hidden from light, hidden from detection, and possibly closer to us than we ever imagined. What if humanity's next home isn't orbiting a distant star, but floating alone in the dark, waiting to be found? In this video, you will discover how rogue planets are formed and violently ejected from their birth systems, why scientists believe there could be trillions of them drifting through the Milky Way, how internal heat and hidden oceans could allow life to exist without sunlight, whether these starless worlds could one day become shelters for humanity, and why rogue planets challenge everything we think we know about life, habitability, and our place in the universe. Welcome to Where the Light Ends, a place where space grows silent, light fades, and the universe begins to reveal its darkest secrets. Rogue planets are not rare cosmic accidents. They are the natural byproduct of chaos. To understand how a planet can end up drifting alone through the darkness of interstellar space, we first need to understand how planetary systems are born, and how unstable they truly are. Every star begins its life surrounded by a swirling disk of gas, dust, ice, and debris. Inside this protoplanetary disk, gravity slowly pulls material together. Dust becomes pebbles, pebbles become rocks, rocks become planetary cores. Over millions of years, planets take shape, carving out orbits around their parent star. From a distance, this process looks orderly and elegant. But inside these disks, it is anything but peaceful. Young planetary systems are violent places. Newly formed planets tug on each other with immense gravitational forces. Giant planets migrate inward and outward. Orbits cross. Resonances form. And when gravity pulls too hard, something gets thrown out. Sometimes that something is a planet. In many systems, especially those containing massive gas giants, gravitational instability becomes unavoidable. A large planet can disrupt the orbit of a smaller one, flinging it away from the star at enormous speed. In other cases, multiple planets interact in a chaotic gravitational dance until one is ejected entirely. The result is the same: a planet torn from its birthplace and cast into the cold between stars. This process is not hypothetical. Astronomers have observed young star systems where planets are actively migrating and destabilizing each other. Computer simulations consistently show that planetary ejection is common, not exceptional. In fact, many models suggest that most planetary systems lose at least one planet during their early evolution. And there is another, even more dramatic pathway. Stars are rarely born alone. They form in dense clusters, surrounded by hundreds or thousands of siblings. In these crowded stellar nurseries, close encounters between stars are inevitable. When two stars pass near each other, their gravitational fields can rip planets away from their orbits. A close stellar flyby can steal a planet, destabilize an entire system, or fling planets into deep space in a matter of hours. In such environments, rogue planets are not mistakes. They are casualties. For a long time, astronomers assumed that rogue planets must be extremely rare. After all, detecting a planet without a star seemed nearly impossible. These objects emit no light of their own. They reflect no starlight. They are, by definition, dark. But then something unsettling happened. As detection methods improved, scientists began to realize that the galaxy was hiding far more worlds than expected. Using a technique called gravitational microlensing, astronomers observed brief flashes of light when invisible objects passed in front of distant stars, bending their light through gravity. Some of these lenses were stars, others were planets, and many of those planets had no star at all. The numbers were shocking. Early surveys suggested that rogue planets might be nearly as common as stars themselves. Later studies went even further, proposing that the Milky Way could contain hundreds of billions, possibly trillions, of these starless worlds. If true, rogue planets may actually outnumber stars. Let that sink in. Most planets in the galaxy may not orbit anything. They wander freely, drifting silently through the cosmic dark, passing through star systems, molecular clouds, and empty voids. Some may travel alone, others may carry moons, remnants of their original systems that were dragged along into exile. And here is where the story becomes truly unsettling, because exile does not necessarily mean death. For decades, habitability was defined by one thing: distance from a star. The so-called habitable zone assumed that life required liquid water maintained by stellar heat. No star meant no warmth. No warmth meant no life. Rogue planets were dismissed as frozen corpses. That assumption is now crumbling. Planets are not heated only from above. They are heated from within. Radioactive decay inside planetary cores produces heat for billions of years. Tidal forces, especially if a rogue planet retains moons, can generate immense internal friction. Thick atmospheres, particularly those rich in hydrogen, can trap heat with extraordinary efficiency. And deep beneath the surface, insulated by kilometers of ice or rock, temperatures can remain surprisingly stable. Some rogue planets may harbor subsurface oceans kept warm entirely by internal heat. Oceans without sunlight, oceans without seasons, oceans that never see the sky. On Earth, life thrives in environments once thought impossible. Deep-sea hydrothermal vents support entire ecosystems, powered not by sunlight, but by chemistry and heat from the planet's interior. Microbes survive kilometers underground, isolated from the surface for millions of years. Life, it turns out, is stubborn. If life can survive without light here, why not elsewhere? This realization has forced scientists to reconsider what it means for a planet to be alive. A rogue planet drifting through space could, in theory, host liquid water beneath an icy shell. It could support microbial life or even complex ecosystems hidden entirely from the surface. These worlds would not resemble Earth. There would be no blue skies, no stars rising or setting, no photosynthesis as we know it. Life would evolve in eternal darkness, shaped by chemistry rather than light. And that raises a disturbing question. If life can exist on rogue planets, how many living worlds have we already missed? Traditional planet hunting methods are biased. We look for planets by watching stars dim or wobble. Rogue planets do neither. They are ghosts in our data. Entire biospheres could be drifting past us unnoticed, silent and invisible. But there is another layer to this story, one that directly concerns humanity's future. Because survival does not always require a sun. A sufficiently advanced civilization could exploit the internal heat of a rogue planet. Nuclear reactors, geothermal energy, and artificial ecosystems could maintain habitats beneath the surface. Thick ice would provide natural radiation shielding. There would be no solar flares, no stellar explosions, no slow death when a star ages and expands. A rogue planet is stable in a way stars are not. Stars burn fuel, rogue planets do not. Once established, a civilization on such a world could endure for billions of years, drifting through the galaxy like a cosmic arc. No orbit to maintain, no star to depend on. Just darkness, silence, and survival. And here is the most unsettling part of all. If rogue planets are this common, and if they can host life, then they may be one of the universe's preferred strategies for preserving it. Not in bright, visible systems, but hidden, protected, and nearly impossible to detect. Civilizations that wish to survive cosmic catastrophes might choose the dark. They might abandon stars entirely. They might be out there right now, drifting past us, invisible, silent, and unreachable. not because they are primitive, but because they are careful. Rogue planets are not failed worlds. They are survivors. They are the remnants of cosmic violence, transformed into sanctuaries by time, physics, and chance. Born in chaos, cast into darkness, and possibly far more alive than we ever expected. If rogue planets were nothing more than frozen rocks drifting through space, they would be little more than scientific curiosities. Strange, yes, but irrelevant to life. What has changed everything is the growing realization that these dark worlds may not be dead at all. Some may be warm, some may be wet, and some, in ways that deeply unsettle our assumptions, may be habitable. To understand how this is possible, we need to let go of one of the most deeply ingrained ideas in astronomy, that life depends on sunlight. On Earth, nearly all life traces its energy back to the sun. Plants convert light into chemical energy. Animals consume plants. Ecosystems rise and fall with solar cycles. For centuries, this made the sun seem indispensable. Remove it, and life collapses. But Earth itself quietly contradicts that idea. Deep beneath the ocean's surface, far from any sunlight, entire ecosystems thrive around hydrothermal vents. These environments are powered not by light, but by heat and chemistry. Superheated water carries minerals from the planet's interior, feeding microbes that form the base of complex food chains. Fish, worms, and crustaceans live their entire lives without ever seeing the sun. Even deeper, beneath Earth's crust, microbes survive trapped inside rock, feeding on chemical reactions driven by geothermal heat. Some of these organisms have been isolated for millions of years. Life, it turns out, does not need light. It needs energy and stability. Rogue planets can provide both. When a planet forms, it inherits heat from its birth. Gravity compresses its interior, radioactive elements decay, and energy is released over billions of years. This internal heat does not vanish when a planet loses its star. It lingers, slowly leaking outward through layers of rock and ice. On a rogue planet with sufficient mass, this heat can be substantial. If the planet has a thick icy shell, that ice acts as insulation, trapping warmth below the surface. Beneath that shell, liquid water can exist, protected from the vacuum of space, shielded from radiation, and kept warm by the planet itself. In some cases, the situation becomes even more extreme. If a rogue planet retains one or more moons, tidal forces come into play. As moons tug on the planet, internal friction generates additional heat. This is the same process that keeps Jupiter's moon Io volcanically active and Europa's subsurface ocean liquid. On a rogue planet, tidal heating could sustain liquid oceans for billions of years. And then there is the atmosphere. For a long time, scientists assumed that any atmosphere on a rogue planet would freeze and collapse. But newer models suggest that a thick hydrogen-rich atmosphere could change everything. Hydrogen is an incredibly effective greenhouse gas. Even without sunlight, it can trap internal heat so efficiently that surface temperatures rise dramatically. In such scenarios, a rogue planet could maintain liquid water oceans on its surface, not just beneath ice. A world without a sun, glowing faintly with geothermal warmth, wrapped in a thick atmospheric blanket, drifting endlessly through space. This is no longer science fiction. It is a legitimate scientific possibility. Now consider what this means for life. Life does not need a star. It needs time, energy, and chemistry. Rogue planets offer all three. They are stable over enormous timescales. They are protected from stellar radiation and cosmic flares by thick ice or rock. Their environments change slowly, predictably, and gently. In many ways, a rogue planet may be more stable than Earth. Stars are violent. They flare, they erupt, they age and die. A rogue planet experiences none of that. Its energy source is internal and steady. Its surface, if buried beneath ice, is shielded from most external threats. Asteroid impacts are rarer in deep interstellar space. Radiation levels can be lower beneath kilometers of ice. For microbial life, and possibly even complex life, This stability could be ideal. But what about humanity? At first glance, the idea of humans living on a starless world sounds absurd. No daylight, no sky, no seasons, no visible universe above, eternal night. And yet, from a survival perspective, rogue planets offer advantages that no star-bound world can. A civilization does not need sunlight if it has technology. Nuclear power, geothermal energy, and fusion reactors could provide reliable energy indefinitely. Underground habitats could be carved into ice or rock, protected from radiation, micrometeoroids, and cosmic disasters. On a rogue planet, there are no solar flares to wipe out electronics, no supernovae from a nearby star, no gradual stellar brightening that slowly sterilizes the surface over billions of years. The planet will not suddenly expand into a red giant and consume its own worlds. It will simply drift. For a species concerned with long-term survival, this matters. A rogue planet could function as a cosmic lifeboat. A self-contained world, carrying a civilization through the galaxy, independent of stellar evolution. If Earth were ever threatened by stellar instability, gamma-ray bursts, or unavoidable cosmic events, a rogue planet could offer refuge. This is not about comfort. It is about endurance. Living on such a world would not resemble life on Earth. Human society would evolve underground in enclosed environments. Artificial lighting would replace sunlight. Ecosystems would be engineered rather than natural. Culture, psychology, and even biology would shift in response to a world without a sky. Children born there might never see a star, and yet they would survive. In fact, they might thrive in ways we cannot yet imagine. Freed from weather, seasons, and natural disasters tied to stars, life could become more predictable, more controlled, more insulated from cosmic randomness. There is a darker implication here. If rogue planets are ideal long-term shelters, then advanced civilizations elsewhere in the universe may have already reached the same conclusion. They may choose to abandon stars entirely, migrating to starless worlds where they can hide, endure, and observe. Such civilizations would be nearly invisible to us. Our search for extraterrestrial life is built around stars. We look for planets orbiting suns. We listen for radio signals from stellar systems. We assume intelligence wants to be seen. But what if intelligence wants to disappear? A civilization living beneath kilometers of ice on a rogue planet would emit almost no detectable signals. No star-to-silhouette transits. No heat signatures easily distinguishable from background noise. No obvious technological emissions leaking into space. They would be ghosts. This possibility reframes one of the most haunting questions in astronomy. Where is everyone? Perhaps they are not absent. Perhaps they are simply hiding in the dark, drifting between stars, beyond the reach of our instruments and our assumptions. Rogue planets force us to confront an uncomfortable truth. The universe may be full of life that does not announce itself, full of worlds that do not shine, full of civilizations that chose survival over visibility. And if humanity ever reaches that level of foresight, we may make the same choice, not to conquer stars, not to build empires around suns, but to slip quietly into the dark and endure. Rogue planets do more than challenge our understanding of habitability. They force us to confront a deeper, more unsettling idea, that the future of intelligence in the universe may not be written in light, but in darkness. These wandering worlds are not just potential habitats. They may represent an evolutionary endpoint for advanced civilizations, including our own. To understand why, we need to think beyond biology and into strategy. Every civilization that survives long enough will eventually face the same problem. Stars are temporary. They burn fuel, they evolve, they flare, destabilize, and ultimately die. Even the most stable star will, given enough time, either swell into a red giant or fade into a white dwarf. Any civilization tied to a star is tied to a countdown. A rogue planet has no such clock. Once ejected into interstellar space, a rogue planet enters a state of cosmic neutrality. It is no longer subject to stellar evolution. orbital decay, or planetary climate shifts driven by changing luminosity. Its energy budget is internal, predictable, and long-lived. For a civilization thinking in millions or billions of years, this stability is priceless. In this sense, rogue planets are not failures of planetary formation. They are platforms for longevity. If humanity ever reaches a point where long-term survival outweighs expansion, conquest, or visibility, rogue planets may become more attractive than Earth-like worlds. A civilization that understands cosmic risks would recognize the danger of being anchored to a star. Gamma-ray bursts, supernovae, stellar instabilities, and nearby cosmic explosions are not science fiction. They are inevitable, given enough time. A rogue planet drifting far from galactic centers, wrapped in ice and darkness, is one of the safest places in the universe. This leads to a profound and uncomfortable implication for the search for extraterrestrial intelligence. We often assume that advanced civilizations would build massive structures, emit powerful signals, and leave unmistakable fingerprints across their star systems. We search for megastructures, artificial lighting, and radio emissions. We assume progress equals visibility, but survival may demand the opposite. An advanced civilization that understands cosmic danger might deliberately minimize its detectability. It might reduce emissions. It might abandon stars. It might retreat underground or beneath ice, prioritizing resilience over expansion. Rogue planets provide the perfect environment for such a strategy. They move slowly, predictably, quietly. A civilization living on a rogue planet could drift through the galaxy for billions of years, observing, waiting, surviving, without ever announcing its presence. To an outside observer, such a world would look lifeless, cold, empty. It would be a lie. This perspective offers a chilling resolution to one of astronomy's greatest mysteries. Perhaps the universe is not silent because it is empty. Perhaps it is silent because intelligence learns eventually to whisper, or not speak at all. Now consider the human future. Humanity is still young. We are loud, visible, and reckless. Our technology leaks signals into space. Our planet glows unnaturally at night. Our ambitions are tied to stars, expansion, and growth. But this phase may not last forever. As our understanding deepens, our priorities may change. Survival across cosmic timescales requires restraint. It requires stability. It requires environments that do not depend on volatile stars or fragile planetary climates. A rogue planet once captured or reached could become a permanent refuge, a place where humanity stores its knowledge, its culture, and its future. Such a world would not be beautiful in the traditional sense. There would be no sunsets, no constellations, no visible universe overhead. The sky would be an endless black void. And yet, it might be the safest home humanity could ever build. Life there would be introspective. Artificial light would define day and night. Culture would turn inward. Mythology would change. The concept of the heavens would be abstract rather than visible. Children would learn about stars the way we learn about extinct animals, real but distant. This raises an existential question. Would humanity choose comfort or continuity? Earth is warm, alive, and familiar, but it is temporary. A rogue planet is cold, dark, and alien, but enduring. Choosing such a world would mean choosing survival over familiarity, permanence over beauty. Other civilizations may have already made that choice. If they exist, they are not out there building glowing empires around stars. They are drifting silently between them, watching, waiting, enduring. Rogue planets also challenge our sense of destiny. We often imagine humanity's future as an outward expansion. Colonies around distant stars, cities orbiting suns, civilizations spreading light across the galaxy. Rogue planets suggest a different path, not outward but inward, not brighter but quieter, not faster but longer. A future where intelligence survives by disappearing. This does not mean humanity will abandon stars anytime soon, but it does mean that the darkest places in the universe may hold the longest-lasting civilizations. That survival may favor those who hide rather than those who shine. And if one day we encounter a rogue planet drifting silently through our cosmic neighborhood, we should not assume it is empty. We should not assume it is dead. We should be careful, because it may not be a wandering corpse. It may be a sanctuary, a lifeboat, or a home, built by minds that understood something we are only beginning to realize. When I started researching rogue planets, I thought of them as cosmic accidents, mistakes thrown into the dark by violent stars. But the more I learned, the more that idea collapsed. These worlds aren't failures. They're survivors. They exist outside the rules we've always believed life must follow, and that realization genuinely unsettled me. If life can persist without light, without warmth from a sun, then maybe survival in the universe isn't about shining brighter. It's about enduring longer. Rogue planets forced me to question whether our obsession with stars is a limitation, not a destiny. And sometimes I wonder if the safest place in the universe isn't under a bright sky, but hidden deep in the dark, drifting silently between the stars, waiting for time itself to pass. This is where the light ends. Thank you for watching. And remember, some questions are meant to remain unanswered.